The topic of this video is generating combinations in Haskell. So, I already do video about key permutations in Haskell, and the main idea of this video is similar to the idea from a previous video. You can watch it before watching this video. Okay, let's start. So what is combinations? For example, if I have some set of numbers represented as list and I want to generate all combinations by 2, selecting 2 elements. So I take 1, I take then the second element I can take 2, and this is the first pair, and then I take 1, take 3, and then I can take 2 and take 3, and that's all. So I didn't pick up the pairs with similar elements here. Okay, let's think how can they do this. First of all, let's define some function which I called comp, and I will use do notation here. The comp is taken a list which represents the initial set. So first of all, we need to take some element from this list, extract. But actually I need to modify this list a little bit at start and I create a new list, enumerated x. I will call it NXS. This list created from XS just using enumeration. So we will use zip function for this and enumerate this list. Okay, now I extract every pair with its number, and at the second step I need to extract second element of my pair, and the list from which I extract this element is built from an XS, and it built it by filtering. So we take an XS and we need to filter it. There's some condition. So we take an XS and extract a pair from it with number n and element y and element y, sorry. And this element goes to our list, but they need some condition here. The n must be greater than the choosable n must be greater than so let's call it nx here, then nx. And now we need to return our pair of elements. So this is x and y. Okay. I think this should work. Yes. Let's check this. Let's compile our module. Comp Okay. I don't know what's the problem. So I think I need to rename a little bit here. Let's go with that. Of course, sorry. I need to extract my my pairs from my new builded list, but I take initial. Okay, it's loaded, and now let's try to some examples. Okay. Com 1, 2, 3 by 2. Oh, sorry, 1, 2, 3. Okay, and we can see that we receive all combinations as expected. So this is pairs without repetition of elements, and this is exactly what we want. But what if I want, if I not only to get pairs, what if I want to take triples and all possible variants of from 1 to n? Okay, this means that I need to add some extra parameter and here and to generate all possible results. And let's rewrite our function. I will call this new function cb and take lists access and take some number. Okay, and now let's rewrite our do notation at first. So I need number at access. So here I will write some expression, and I need an access here and some lambda function which takes every element of this list. Of course, I need to define an access. And an access is zipped access. Okay, and lambda is, what is a lambda body here? First of all, we need to call again our cb, but we will with the task of a lower level, and from this lower level we construct our solution, final solution. How we reduce the level of the task? Of course, we need to we need to reduce n here, and here we need our filtered lists. And of course here I don't take x, I want to pattern match this pair which I extract from n access. I'll call it nx, number x, and x. And here I generate a list a list. Of elements Z. So actually I can take it from here, I think. I can take it from here. Yes. And I need some final step. I need to take these results, of my setback function, and I need to add my selected x to every result of lower task, and I do it using fmap and partially applied list const operator. Okay, and I think this thing should work. Let's try to recompile this. Yes, it works. But I need to add extra case here at the bottom level of my recursion. No mat list I got here. If I get 0 here, I need to return a list with the empty list. So let's recompile. Let's call our try to call our CP function with some list and the get all pairs. Yes, it works as expected, and we can get triples here. Yes, I think this is correct. And of course we can get results with n equal to 4 and so on and so on. So this is our final solution. I think this is very nice and clean, and to understand how can we generate all possible combinations. So thanks for watching. Push like button, push subscribe, write comments, and sorry for my English. Bye.